we need to show that G inverse is exactly the same as G over here in order for us to show that G is self-inverse. Okay, so the first thing that I want to do is I'm going to try to find what is the domain of G inverse, and domain of G inverse is going to be deduced from the graph of G. And the expression here tells me that the graph of G is going to follow one that is of a graph of a rational function that we've discussed in graphing techniques, and this is in fact the second type of graph of rational function that we have mentioned before. So for this graph, other than having a vertical asymptote of x is equal to 1, I know it is going to have a horizontal asymptote of 1 divided by 1. Okay, the coefficient of the highest power over the coefficient of the highest power. So 1 over 1 is going to have a horizontal asymptote of y is equal to 1, okay, which means that the graph of this will have two possibilities. Okay, when y is equal to 1 is here. One possibility is when the graph takes a shape that is something that is like this. Okay, the other possibility is when the graph takes a shape that is something that is like this, okay, where this is still y is equal to 1, okay, which means that the range of G, it is going to be from minus infinity to 1, not inclusive of 1, and from 1 to infinity, and this will become the domain of G inverse. Okay, this is part 1 that we are doing. Okay, so with this, I want to next try to find the expression for G inverse. To find the expression for G inverse, I'm going to let y be equal to the expression for G, which is x plus k over x minus 1. And let's try to make x the subject, right? Because this will help me to find another process or another expression that can help me to reverse the output s to become now the input. Okay, so this is, I'm going to try to make x the subject. So cross multiplying xy minus y, this is equal to x plus k. We bring this over to the left hand side, xy minus away x. This is going to be equal to y plus k. So x of y minus 1, this is y plus k. So x is equal to y plus k divided by y minus 1. Okay, from here, I now know that G inverse, it is going to take up an expression that is of x plus k divided by x minus 1, which is exactly the same as the expression here. And the domain of G inverse, if I were to apply it here, it will also be such that x, which is all real numbers, and x cannot be equal to 1. Okay, and that is why we have shown now that Gx, okay, it is exactly the same as G inverse x, okay, and that is why G is self-inverse.